So let's continue on. Now, in this next hour and a half, we're going to be using NodeXL. And I'll be going over some of the concepts that I've already introduced, and I'll be introducing new concepts about networks. My aim in this section is that by the end of this hour and a half, you'll be able to create your own social network data within NodeXL, and you'll be able to look at some properties. You'll know how to construct or look at properties of nodes and also properties of the network as a whole. And I'll point to you to some of the key properties of networks and nodes. And then I hope before we go to lunch, we'll try to collect some data, some live data from the web. Okay, and then we have a set time after lunch where we'll continue on looking at Facebook and Twitter data. But to start with, we're not even going to be thinking about social media data. We're thinking about NodeXL. How would I use NodeXL to study a friendship network? Okay. So what I'd like you to do is on that page, the web page that I provided before, I have there's a link to a PDF called NodeXL exercise _ friendship.pdf. So if you open that up, so I'm going to be taking you through the steps in this exercise, and you can follow on the screen and do it yourselves as you go, but you can always refer back to this PDF if you're getting behind, or if you can also be referring to it if you want to move ahead. So you should all have NodeXL open. Now you all have the kite network there, but I actually want you to close that. I was just opening up that just to make sure that it would actually work. NodeXL would work. Actually, I don't know how to close it without closing NodeXL entirely, so I closed NodeXL entirely and then I'm going to reopen it again. So I just recommend you do that again yourselves. So we want NodeXL with no data loaded up in it. We're going to start by entering edges into the spreadsheet. So the important thing to see here is that there are two parts. there are worksheets here. Make sure you've clicked on NodeXL. Up here are the different NodeXL commands that we'll be working with along this ribbon here. But the first thing to look at is the actual worksheets down here. And when you open it up, to begin with, it's open to the edges worksheet. Okay. Now, remember, I use the term edge is otherwise known as link or tie. So you just need to know that the terminology gets used in different contexts. The NodeXL people use the term edge. Okay. And they don't use the term nodes, they use the term vertices instead of nodes, okay? But just remember, they're the same thing. So we're going to enter in some edge data for a friendship network. So imagine that we've gone to a school room, and we've gone to a primary school, and we've to a classroom, and we've said, okay, tell me we've gone and interviewed each person and we've said, okay, tell me who your friends are. Okay? So I'd like you to enter in the data as it's shown in this spreadsheet, in the PDF document. So and here I'm going to enter Anne. And next to her is Bob. So Anne is friends with Bob. Bob, Carol, etc. So if you just work your way through. So these are, we can think of these as being either directed or undirected. I think to begin with, we'll just think of it as an undirected network. So we know that Anne is friends with Bob, Bob's friends with Carol, etc. So we've entered in the edge data. Now if you go and press Show Graph, you'll see what this network looks like as a sociogram. So Show Graph is up here. Well, now it's showing Refresh Graph, but before I hit it, this button here was Show Graph. Okay, so if you click on a node, it will highlight all of the edges that that node is participating in the edges spreadsheet. But it'll automatically show the edges there, and it'll highlight them in red. If you go to the vertices sheet, now you see that automatically the vertices have been entered in there. And again, if you click on a vertex here, it will show it. It'll highlight the vertex in red, and it will show all the connections that that vertex is participating in. Okay. So that's how you create a social network in NodeXL. So NodeXL is great software in the sense that it's already in the familiar Excel environment, and very quickly you can get up to speed with using quite sophisticated social network analysis techniques, and also you can create your own social network data within there. Personally, I don't use NodeXL for my own research. There are other tools that I use, but I think in terms of getting up to speed, and in certain contexts, NodeXL is all you need, really. The thing I like about NodeXL is that it has these plugins for collecting social media data, which is what we'll be looking at today. But there are other social network analysis tools out there, but I think NodeXL is very intuitive, very nicely designed, and it's within the sort of the familiar Excel environment. So, working through our exercise here, well, we've got our nodes and edges in the data, but what we would like to do is to put in some attribute data. So we would like to have the node shape and colour reflect particular attributes of these people. So how do we do that? Well, we scroll across in the vertices sheet, we scroll across to column AC where it says add your own columns here. And we're going to add a column called gender. It should be sex, apparently. I get people tell me off for calling this gender rather than sex. Anyway, this is the economist in me. We refer to it as gender. And I'm going to enter the gender of each of these people. So F for female. I mean, you could do it exactly in the exercise, or you can just use an abbreviated form. So F, M, F, M, 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 and then F. So I've entered whether they're male or female. And then we're going to add another column, which is age. And just following what's in the exercise. So remember, these are kids that we've interviewed. So, and 11, 12. Okay, so we have our attribute data in there. How do we get it reflected in our network? I'd like the node colours to reflect gender. And I know there are easier ways of doing this. In the exercise, I've given you an if statement that you can use to get blue and red representing the gender. You can do that in your own time. Because we've got such a small amount of data here, I recommend that you just write the colour in yourself. So red for girls, blue for boys. Okay, standard convention here. And then you hit refresh graph, and you should be getting now the node colours reflecting the gender. What about node shape? I'd like the node shape to reflect or to be proportional to the age of each person. So to do that, we need to use a different function, which is autofill columns. So up here, you click on autofill columns. And by default, it opens up to the edges tab, but we want the vertices tab. And I want vertex size to be proportional to age. So I select age in against vertex size. And then I press autofill, and automatically it does it. It updates the graph for you. One thing to note with this is you've got to be very careful where you put your data. If you write over these columns here where it says things already, then you basically mess the worksheet up and it won't do what it's meant to do. So when you add your own attributes, you've got to make sure you go out to this part where it says other columns and you do it from there onwards. You don't add anything back here unless it's what I'm telling you to do, which is where I said write red and blue for colour. Because once these columns get messed up, then that's kind of it for your worksheet. Okay, so one last thing I would like us to do is we want to have some names here. Okay, so at the moment I click on here and I can see over here that this is Anne, but we would like the names to be showing in the network map. So we want to add some labels, and to do that, you could copy and paste the vertex name across to the label column, and that would work. You can also do it via autofill. Oh, actually, no, you can't. Yeah, vertex label, and we're going to set it to just equal to vertex. Okay. And now we've got their names. So that's your first social network in Node Excel. So we have some attribute data in there, but we have our own, it's the intrinsic attribute data, so it's their age and their gender. What about some of their network-related attributes, like attributes reflect their position within the network? How do we compute that? Well, the way we do that is we go to this up here, graph metrics. We open up the graph metrics dialog. And what I recommend, so what Node Excel does is by default it does not compute graph metrics. And the reason why it does that is because it won't auto-compute them. Because some of these graph metrics take a long time to calculate if the network is big. And so you typically want to have some control over what you ask it to compute. For a network of this size, we don't have any problem with it taking too long to compute the graph metrics. So we're just going to select all there. Okay. And some of these are not even relevant for this network, but it doesn't matter. And then you press calculate metrics. Okay. And now we're at a point where I can start introducing some more of the technical social network analysis terminology. There are two types of metrics that we're interested in, and when I use the term metric, I just mean it's an empirical, it's a numerical measure of relating to the network. There are two types of network metrics. There is one that relates to the network as a whole. So these are metrics that refer to the structure of the network as a whole. And by default, after you press graph metrics, you come to this sheet here which says overall metrics, and these are network level metrics that are being provided. Some of them are very easy, vertices. It's the network size. It's the number of nodes in the network. It's the number of unique edges. It shows the number of unique edges. Number of loops, so that's where a person connects to themselves. There is some other ones here. I'm not going to go into a lot of these details, but connected components. So a component is a collection of nodes who are connected to one another. And you can see here, it's not very clear from the way I've drawn this one, but if I lay it out again, oh, it's still not showing very clearly. Maybe with this. Yeah, you can see it now. These two nodes connect to one another, but they don't connect to the rest of the network. So they are what's called a connected component, while the rest of them are a second connected component. So, okay. Another one of interest is the maximum geodesic distance. So that's the diameter of the network. So what that is that if you, it's the number of steps, the maximum number of steps from each node to every other node. Now I don't know how NodeXL handles when you've got a network like this where there are two components. Possibly it just does it for the largest connected component, which is this one here. But you can see, let's just ignore Helen and Gary. There is what this is saying is that there is a maximum of 3 steps from any one actor to all the other actors. So if you want to go from Frank to Bob, it's 1, 2, 3 steps. Or 1, 2, 3 to Dave. At most, every actor can reach another actor with just at the most 3 steps. Average geodesic distance is the average shortest path. It's averaged over all pairs of actors. These metrics are often not that useful in the context of a single network. It's where they become useful is when you're comparing different networks, or maybe looking at networks over time and how they're changing over time. That's where you can get analytical insights from these network level metrics. Graph density is important. What that is it's the proportion of the maximum number of potential ties that have actually been realised. So it's saying, what this is saying, it's 0.25, and it's saying that of all of the possible ties that could be formed in this network, 25% of them have actually been created. So again, network density, you look for a given network, it doesn't mean a lot. But when it can be interesting is when you're looking at maybe a given network and seeing how things are changing over time. Is it becoming more dense? So are more connections being made, or is it becoming less dense? Or comparing different types of networks at a point in time, that it can become quite interesting then. Okay, so that's network level metrics. The other type of network metric is node level metrics. And so these are metrics that refer to the individual nodes within the network. And how do we see those? Well, we go back to our vertices spreadsheet, and if we scroll out, we'll see that actually they've been computed for us now. So degree is the most sort of common and important one. This is just the number of connections that a person has. So Anne, the degree for Anne is 2. So if I look at Anne, and sure enough, she's connected to Carol and she's connected to Bob. So that's her degree of 2. Carol is the most connected with 4. And now what we could do is we could redraw our graph. We might say, okay, we're not interested in showing our network with node size reflecting age. We might be interested to have node size reflect degree. So therefore, the person who has the most connections will be have the biggest node. So the way we do that is we go back to autofill columns, and we change vertex size from age to degree, and then press autofill. And there you go, it's changed for us, and Carol is the node for Carol is the biggest because she's got the most friends. And then there are other metrics out here that are worth quickly talking about. I mentioned this idea of betweenus centrality before. Well, NodeXL has computed betweenus centrality for us, and it's a measure of the way it's computed is it looks at all of the shortest pathways between all pairs of actors. And then it finds the proportion of those that pass through each given actor. So Carol has the highest betweenus centrality, and what that's saying is that more of the shortest paths between all other actors pass through her. And you can sort of see that she's quite central in the network. On the other hand, someone like Dave, he's got the lowest betweenus centrality that you can find. Of 0, and that's because connections between the shortest paths between other actors, none of them pass through Dave, so he's got the lowest possible betweenus centrality. Closeness, centrality, I'm not giving you the mathematical formula here, I'm just kind of giving you a bit of the intuition behind it. Closeness, centrality is a measure of to the extent to which an actor is central to all other actors. And again, Carol has the highest closeness centrality of 0.167. Eigenvector centrality, I will ignore that for the time being, and page rank. Clustering coefficient, that's quite interesting. That is a measure of the density of each person's ego network. So it is interesting to know the structure of people's ego networks is quite important and interesting. And an example is this. So if this was me and I had, and these are the people that I'm connected to. So this is my 1.5 degree ego network. And say it looked like that. That was it, okay? So of my alters, only 2 of them know each other. In contrast, say this is Karen's 1.5 degree ego network, and it looks like, say it looks like this. So, something like that. Her alters all know each other, okay? Just assume that. Or a lot of them know each other. And maybe that person knows each other. Okay, so would you say, looking at those 2 ego networks, I mentioned before the concept of strong and weak ties. Who do you think's got the most, who's got the weak ties in their ego network? Me, yeah. I've got the majority of my ties, my ties are weak ties because my friends don't know each other. So these could be people I know through different parts of my life who don't know each other. So someone I know at the sports club, not that I go to one, someone I know at work, someone who I know, some other part of my life, and they don't know each other. Well, these might be showing her close friends from work or close friends from school or something like that, and these are her strong ties. We can assume that we are receiving different types of resources from these networks. I'd probably be receiving quite a lot of innovative information because my friends don't know each other, so these weak ties are a source of information. Sometimes my ties are not redundant in terms of the information they can provide. If they all knew each other, then they all know the same information. So weak ties are often a source of innovative information. While on the other hand, strong ties, they provide other things. They provide support, they provide kind of emotional kind of strength, etc. So the structure of an ego network in certain contexts is very interesting and important. And social capital is often operationalized using ego net structures like this. That maybe Karen has different types of social capital to what I have, based on our ego net, but it's purely based on the structure of our ego networks. The way it can be reduced to a single number is by looking at the density of the ego network. So Karen's ego network has a high density because of a lot of the potential ties between her friends have been realised, while my ego network would have a low density. And that's what's been computed here in the clustering coefficient. It's the density of the ego network. So if we look at Anne, her clustering coefficient is 1. And that's because Anne has got 2 friends, Carol and Bob, and they are both friends. So all of the potential ties in her ego network have been realised. Okay. In contrast, Carol, let's look at Carol's ego network. She's got Anne, Bob, Ed and Dave, and only one of those ties between the alters has been realised, and that's between Anne and Bob. So 0.167 of the density of her ego network is 0.167. So looking at this, you would think that, Carol has, these are weak ties in the sense that she's friends with people who typically don't know each other. Okay. So that is, that's about it for that network. I would like to, I think we've gone through all of the exercise for, yeah. What I'd like you now to do, we're going to do one more demonstration before we move on to actually trying to collect some data through the web. We're going to look at this kite network again. Actually, no, we're not. Let's take that back. We're going to open up a blog network. So what I would like you to do is go to the web page and download the datasets divided they blog. Okay. And can you download it to, remember you've got to download it to the temp directory that we created, or else we won't be able to open it. So you've got to do a save link as, and make sure that it goes into the temp directory. Now, before you open this up, you might want to save the network that you've just constructed, so you can look at it again later. So you do that just by saving it as a worksheet as normal. But I want to let you know, for the way the computer lab's been set up, once again, if you save this into any directory other than that temp directory, then you won't be able to open it up again in Node Excel. For your computers at home, you'll find that if you save it to the documents directory, it should be fine. It's to do with a Microsoft security thing. So what I'm going to do is I'm going to save my friendship network. I'll call it Friends. And I'm going to save it to the directory we set up. So D temp. And then I'll be able to open it up later. And now I'm opening up the divided they blog dataset. And press show graph, and it should look something like that. Okay, so now we've got a network of bloggers. So I mentioned before, I showed you the visualization of the divided they blog dataset. That was 1,500 bloggers. But Adamich and Glance had another blogging dataset that they collected, which was for what they call A-lister blogs. So these are kind of the big name bloggers at the time, A-listers, and they got the top 20 conservative political bloggers and the top 20 liberal liberal bloggers at the time, and they found how they connected to one another. And this is their data set. And so what I would like you to do now in the next 10 minutes or so, I would like you to do exactly what we just did for the friendship network data. We'll go through some of those similar steps. I'd like you to get the node color to reflect whether or not these are conservative or political bloggers. And I've already got the data there add your other columns. It's conservative, it's showing you the political leanings there. So I'd like you to get node color to reflect whether or not they're conservative or liberal. You can use whatever colours you want, but if you want to fit with the convention with regards to US politics, it's red equals conservative, blue equals liberal. I would also like you to show the node label, get the node label to reflect the actual website, the vertex name. So I'll put up, you get working, and I'll put up a list of my polite demands that I'd like you to go through. It can be a bit of a pain to be writing out red, blue, etc. So a way to do this more quickly is you could use autofill columns. Now, actually one of the things I need to do is I need to just put a column name there. So I'll just say leaning, okay. Makes sense to me, if not to anyone else. Autofill columns, vertex color, and if I do leaning there, it should give me a color. It may not make sense. Okay, and it didn't. Okay, forget that. This is where I use the if statement. I go if and then I click onto this column, this cell here. If that's equal to conservative, then red, otherwise blue, and then close the bracket, and then it should, okay, it hasn't worked. Maybe I need to do a string. Yeah, okay. You need to put inverted commas around. So this is a an if statement in Excel. There's probably another way of doing it, but this is the way I prefer. So the command is you set equals if, and then it's a command. It's a Boolean logic statement here. So if this first statement is true, then set this cell equal to red. If it's otherwise, set it equal to blue. That's a way to kind of easily do that. So something to note here is in our previous friendship example, that was an undirected network. Now we're working with a directed network. And so I used the term degree before, but that's incorrect. I should have been talking about in degree and out degree. So when the network is undirected, NodeXL will compute degree, and that's just the number of connections that each person has. But when the network is directed, then you have two measures of centrality. There's in degree and out degree. So in degree is the number of inbound connections, and out degree is the number of connections going outwards that are being made by the actor. And so what I'd like you to do is make node size be proportional to in degree. I should have specified that earlier. So we go back to graph metrics. I'm going to compute them all. And it says here, actually, it says vertex degree, undirected graphs only. So it won't compute it if you've got a directed graph. How do we know our graph's directed? Because we can see arrows here. The other way is because it tells us up here, it says type directed. Okay, so I'll compute them all. And now I'm going to do, interestingly, it always takes us to the design tab after doing that. So, and now I'll do autofill columns, vertex size, proportional to in degree, autofill. And now it's showing us that. Okay. Yeah. So a couple of other things that we'll quickly look at with this data set before moving on to trying to collect some live data. Now, there are different ways of visualizing networks. The standard algorithm is this FR algorithm, but you can select other ways of visualizing it. And depending on your application, it may have a big impact or it may not have much of an impact at all. But I just changed it to this Harrell core and fast one, and for me it's showing greater amount of structure here. The clusters are more obvious. There are others in there that make, I don't really even know why you'd want to lay it out. Well, it can be actually quite interesting laying it out as a circle like this as well. You're getting it's positioning them next to each other if they have more links shared amongst the groups. So you are seeing that there is this clustering here still. Okay, there are lots of other features that I can show you, but it's probably best if we move on to collecting some live data, and we'll see how that goes. And as we proceed, there'll be other aspects of NodeXL that I'll mention to you that are relevant in different contexts. Essentially, there's a lot that we can do that I haven't shown you yet. but I'll show it to you hopefully over the next, the end of this session and the session after lunch. So what I would now like to do is move on to shift the focus back to social media. This is a table that's out of a paper that I just finished writing with a colleague, where we're trying to come up with a typology of online networks. You can see here it's online networks by direction and manifestation of ties. So in the columns, in the rows, we've got manifestation of ties, and it says explicit and implicit. And so this explicit means that the actor is making an explicit decision to make the connection, while implicit means that the connection is not being made explicitly. It's being derived from the data in an implicit fashion. Direction of ties, well, we already know this, undirected and directed. And so an example of an explicit manifestation of ties where the ties are undirected is a friendship network like Facebook. Okay? Each actor has to make a conscious decision to link with another actor, but the ties, at least as they are observed by us, are undirected. Once the Facebook friendship is formed and it becomes visible to a researcher, we don't actually know who initiated the friendship, so there's no direction of the tie. An example of directed ties where the manifestation of the tie is explicit is a microblog network, such as Twitter. I keep talking about Twitter because that's the one that I know about, but Sina Weibo is one of the microblogs in China that has quite similar features. Well, very similar features, but actually interestingly different behaviour. Like Chinese microbloggers act differently to, so-called Western microbloggers in terms of their behaviour within the microblog, and that's research that I'm quite interested in, is kind of cross-cultural differences in retweet behaviour and things like that. But we won't go into that here. But these are directed ties, and they are explicitly created. Okay. Today we're just looking at these two groups here. Okay, but I'll quickly mention this row. So where the ties are in the manifestation of the tie is implicit, but then the direction of the tie is undirected. Well, an example of that is a semantic network. I mentioned before about the social tagging systems, how it's possible for you to create a semantic network. So that means a network of words where there is a link between two words because both of those words have been used to tag, for example, a photo in Flickr. And so you might have a link between cute and cat. So in a semantic network, it could look like that. So there's two nodes, cute and cat, and there's a link between them because someone on Flickr has tagged a photo as being the subject of the photo as being a cute cat. Okay. There's a lot of interest in semantic networks by computer scientists, less so from social scientists' perspective, although I'm kind of increasingly interested in semantic networks. The reason why social scientists are less interested in semantic networks is because it's actually pretty hard to think of these as being social networks. I mean, they are socially generated networks, but they're not really social networks. I mean, the actors are not people, they are words. Okay, but then the other example over here is where we have directed ties, but the ties are implicit. Well, in our paper, we're classifying blogs and World Wide Web hyperlink networks and news groups in this category, but I don't completely agree with the categorisation that I've subscribed to, because I actually study World Wide Web hyperlink networks as examples of directed, explicit networks, in the sense that an organisation makes an explicit decision to create a hyperlink network to another organisation. But I think the reason why we're putting these in this group here is because it's got to do with how you actually interpret a hyperlink. It's quite easy to interpret a link in Facebook between two people, but how do you interpret a link between two websites? It doesn't necessarily indicate that there's a real world. I mean, the real world, you have to make an inference as to what the real world connection might be between the two organisations. And if you're trying to do this at scale, which is the sort of research I'm interested in, where I'm not, I'm collecting large quantities of data, and I'm not going and asking each organisation, well, why did you create a hyperlink network, a hyperlink to that organisation over there? You then have to, it becomes very difficult to interpret the meaning of a hyperlink. And so the research I'm involved in, it gets down to, well, what types of organisations are you studying? And so if you're studying environmental activist organisations like I have, then what we infer or interpret a hyperlink as meaning is we interpret it in the context of collective identity formation on the web. So I'm not going to go further into hyperlink networks today. I would have loved to have done it, but I wanted to kind of stick to more interpersonal networks. So we're focusing on Facebook and Twitter. So how can we collect Facebook data using NodeXL? Well, if everything, yeah, okay. Actually, we're going to focus on Twitter data to begin with, okay? So if you look at NodeXL, there are three, there's a menu called import. This is how you get data into NodeXL. Well, there's two ways. You can either import a worksheet that you've already created before, which is what we've done up until now, but you can actually import network data from other sources. So these sources up here are where you've got a network that's been created with other software, and you've exported the network in a format that can be then read into NodeXL. And the formats that NodeXL accepts are GraphML and PIAC and UCINet. And UCINet and PIAC are different other social network analysis tools. And then down here, we have a series of importers from the live web. So you can import data from Flickr, Twitter, and YouTube. Okay. This is the default NodeXL installation. There are these plugins that you can install that allow you to collect data from other social media environments, such as Facebook. I wrote, well, with a colleague at the ANU, I developed a plugin to allow you to collect data from the web, the World Wide Web, so blog networks or hyperlink networks more generally. What we're going to look at is the Twitter network. And now, this is where you need to have a Twitter account to be able to collect these data. If you don't have a Twitter account, then don't worry, because I'll be able to show you Twitter data sets that I've already collected that are downloadable from the website. But for those of you who do have a Twitter account, then I'll take you through the steps on how to create to pull down data from Twitter. Now, I'd like you to follow my instructions very carefully here. The reason is because it's actually very slow to collect data from Twitter. And if you specify a data collection where you're specifying to collect a lot of information, then the computer will get tied up and you won't get any data at all. So it's quite literally it'll just stop working and it'll sleep for 15 minutes and then it'll start working again. So Twitter are increasingly making it hard for people to get access to their data. And there are these Twitter resellers that we're supposed to go through, but they are actually charging too much for academic researchers to afford. So really, what I'm showing you is just a way to collect a small network. If you're wanting to do large-scale network collection, then you can still do it through NodeXL, but you might have to leave your computer running overnight, for example, to collect all the data. But we don't want to be having our computers tied up today. So there are three menu items here relating to Twitter, and I'm going to begin start by showing you the search network. And so again, please what I'd prefer you to do is to not do anything just yet, and I'll show you on the screen how it's done, and then you can all, while I'm doing this, you can think of a term that you might like to search on, but I want you to follow my steps carefully, or else your computer will get will get sort of tied up. So what you do is you start off by specifying a hashtag or a search term that you're interested in. And so this is a way to isolate a particular conversation on Twitter that you're interested in. So it might be that you're interested in the Tour de France, and what's the latest what are the latest tweets out there about the Tour de France? Does anyone know a hashtag for the Tour de France? I used Le Tour, and that seemed to work, but okay, no, there's no Tour de France fans here. But the problem with that was that a lot of the tweets were not in English, so I got stuck with that. Look, I think I'll stick with the NodeXL advertising here. Mark Smith is he's doing a bit of brand building through his search interface here. So we'll search on NodeXL. Okay. So this means that I'm going to collect tweets that have mentioned NodeXL, and it may be because it's a hashtag, or it might be just that someone's just mentioned NodeXL in a tweet without it being a hashtag. And then you get to specify the types of edges that you want to collect data on. Replies to, mentions, and a tweet that's not a reply to or a mention. Now, this is where I need to actually give you a bit more of an intro to Twitter. So, apologies, we're going to just sort of come back to that. I need to explain exactly the type of networks that you can extract out of Twitter. So, this is from a chapter from the NodeXL book. There's some background there on Twitter that I've already discussed. Firstly, there's friends and followers. So people who subscribe to and receive your messages are your followers, while the people who you're following are called your friends. Now it's interesting, this used to be the Twitter terminology that they were using, and that's what was in the NodeXL book. And I was recently presenting on this, and someone said, "Oh, that's really interesting terminology that you've come up with. You know, that helps me to understand Twitter better." And I said, "It's not my terminology, it's Twitter's." And they said, "No, I've never seen Twitter refer to followers and friends." And it turns out that Twitter have changed their terminology. So they refer to followers and following, okay? So followers are the people who are following you, and following are the people who you follow. And yes, anyway. So just a word of warning, okay, a word of warning. But anyway, I use followers and friends, okay. So that's one way of collecting network data. Another way is through what's called @replies. So that's where your tweet, you include a username of another Twitter user, and you precede it with an @ okay. And that means that the tweet is intended for a particular user. So the example out of the NodeXL book here is A tweets, "I'm using NodeXL to visualize my Twitter network." B says, "I'm making scrambled eggs for breakfast." I would say this is a very realistic Twitter stream here. It's like, okay, we're very interested in that. And then C says, "So am I." And then, you don't know who C's referring to, but when they use @replies, C at the end says, "A, so am I," meaning he's replying to user A. So C is saying, "Yeah, I'm using NodeXL too." Okay. So @replies are possibly a better indication of the existence of a social tie between two users rather than the friends and followers lists. So in blog research, you often find people want to make a distinction between what's called blog roles. So these are lists of people that you have on the side of your blog page, and these are kind of like your favorite bloggers. These might be bloggers who are kind of similar to you, or you think that your readers should know about. That's what's called a blog role. And then you can think of what's called permalinks or post links. And so these are links to bloggers that are actually in the posts that you're authoring. So if I'm making a commentary on NodeXL and I want to refer to Mark Smith's blog, then I might actually say he's written something about Node Excel and I'm, saying, oh, I don't agree with that, or I did it differently, Mark, I would actually make a link to his post to indicate that, what I'm referring to. And that would be that's known as a permalink. And blog researchers often like to focus on permalinks because they regard it as being a better source of current connections or conversations between people. And in the same way, some researchers prefer to use @replies as an indicator of a tie between two Twitter users compared to follower lists, because follower lists can become stale. One of the things about social media is that it's great for studying friendship or tie accumulation. It's less useful for studying tie dissolution because people don't tend to remove links. Once you become Facebook friends with someone, the cost of maintaining that friendship is zero. And so a lot of people don't actually, I can ask the group whether they agree with me, but my understanding is that often you don't end up kind of removing Facebook friends. They can become quite stale. Do people agree? Or, because I can see you don't agree, no? No. You unfriend, do you? Yeah, okay. So a lot of people don't unfriend. I mean, I've unfriended someone in LinkedIn, but in Facebook, I'm not actually an active user of Facebook, but there are lots of people there who, I don't, I've just accepted them at one point and I could probably remove them, but I can't be bothered getting around to it. So my Facebook profile, at least, is not really necessarily indicative of my, actively maintained friends. And people say the same thing about Twitter, that, if you're following someone, I guess maybe with Twitter, if you're following someone and you don't want to follow them anymore, then because you're sick of their tweets, then you might want to stop following them.
You can do something similar with Facebook, because on your news feed, you constantly get news from people you're not interested in. You don't need to really defriend them.
Yeah.
What you do is
you say I don't only post. You filter who's going to post to your. Yeah. I've tried. Yeah.
And there's degrees, so you say.
Yeah.
Give me news feeds of
yes.
this person, all their news feeds, or just relevant.
Yeah. Yeah. I've tried to do that actually, and I got frustrated because I was just getting stuff I really didn't want to be.
Clunky compared to the filters that blogs have had for ages.
Yeah. Okay. Yeah. And for me, it doesn't seem to work. So it's one of the reasons why I just have a lot of trouble engaging with Facebook, because I got sick of, seeing certain photos and things and news that I wasn't interested in. Anyway, so a problem with @replies is that they can be used to simply mention another user, not direct a tweet to them. So Twitter get around this by distinguishing @replies from @mentions. So if the tweet starts with it will be an @reply. Otherwise, it will be an @mention. So these are examples. So this person tweets, I just saw @redlog get hit by a bus, bummer. So that's an @mention. So this person is mentioning redlog in their tweet. While if they wrote @redlog, that bus must have hurt, this is an @reply. So this is much clearer indication that this tweet is actually being directed to this person, while this one it's, there's an acknowledgement of this person, but it's not actually necessarily a conversation. So these are much more indicative of one-to-one connections, I guess. And hashtags, I've already started to talk about hashtags, but they are used to identify particular topics that are being tweeted about. So my research with Twitter generally starts from finding a subset of tweets that are irrelevant to what I'm wanting to research. And so I've done some work on Occupy Wall Street, and I use hashtags to identify tweets that are relevant to Occupy Wall Street. Retweets are another important form of networking. This is where it's like forwarding an email. That's basically what it is. So here is an example of retweets. ASA News, so that's the American Sociological Association News. These are from the Node Excel book. Their tweet was, New York Times columnist Dave Brooks touts social science sociology as the new physics in economic theory. And then Redlock is retweeting that tweet. So he's using this convention RT and then he puts the tweet verbatim. And then Vlad's come along and he's retweeted Redlog. So you can see how it's kind of it's just like forwarding other people's emails. And NodeXL is able to pick up retweets as well. So let's get back to NodeXL. Now you have some context to this particular dialogue here. You're able to add edges for you're able to select what types of edges you're wanting to collect data on. By default, it ticks replies to, so it's at replies, at mentions, and tweets that are not replies to or mentions. So these are tweets that contain the hashtag, but they don't contain an at reply or at mention. You're also able to select follows relationships, but as it says here, this is very slow. So for my initial data collection, I'm not going to tick this. If you want your computer to be tied down and unusable for half the day, you do that when you tick. If you tick this, that's the risk you're taking. Although it depends on how many tweets you collect. So the other thing that you can do is limit to the number of tweets that it's going to pull down. So by default, it's collecting the last 100 tweets on that mention that hashtag. I'm going to stick with the default, okay? And then you've got two more checkboxes. You can add a tweet column to the edges worksheet. So I'm going to select that. And you can add a statistics column to the vertices worksheet. I'm also going to select that. And then I'll show you what data that collects. Okay. Maybe I'll cut this down to... No, look, I think for NodeXL, it's not that risky, so I'll stick with 100. The risk is that you get... I'm not collecting follows relationships, so that's okay. Now what you need to do is you need to authenticate Twitter to collect the data. And for you'll be finding that everything is blanked out except this middle option here where it says, I have a Twitter account, but I've not yet authorized NodeXL to use my account to import the Twitter networks. So what you do at that point, and I'll walk you through it later on, is you actually need to, you click that and then you press OK, and then it's going to take you to Twitter where you sign on, and then you get a PIN number that you then have to enter into NodeXL. And then you're basically giving NodeXL access to your Twitter account, okay? So but don't worry, these guys are not dodgy, so there's nothing about the worst thing that could happen, but I don't think they do it for the Twitter collection, is they sometimes like to put out a bit of advertising in your feed. So last week when I was doing this with Facebook, I think it turned up in my timeline or my feed saying, hey, I'm using NodeXL. And so it's like my endorsement of NodeXL, which I didn't want to do, but I wanted to use NodeXL, so it's kind of like, I had to agree to it. So, but I think you're okay with Twitter. They're not going to start authoring tweets for you. Okay, so I don't need to authenticate because the IT person has already done that. So I press OK. So I just took you through the steps. I was doing it quickly, but you saw how I had to enter in my Twitter username, and then it gave me a PIN number, and I just copy and pasted that into NodeXL. It should remember that after that. Then I just pressed OK or continue, and down the bottom you could see it was collecting its data. So now by default, NodeXL will read new data into the existing spreadsheet. It will write over the existing spreadsheet. So I've just had all my vertex data for the Divided They blog spreadsheet overwritten with the Twitter data. The network is still showing the Divided They blog, but I can see here that I've got new vertex data here and new edges data over here. So just to show you that it's worked, that's what the new network looks like. So what I'll do now is, and we've got about 15 minutes before we break for lunch, I will just quickly show you what are the new features, what are we actually pulling down from Twitter, and then we can spend some time and you can do a data collection of your own. So Most of this is very familiar. The Vertex is now, so the Vertex names are just the Twitter usernames. So we've got Mark Smith there. He's the main person behind NodeXL, and he tweets a lot about NodeXL. So I expect him to be very central. I'm betting that that's Mark there. Well, actually it is. I just clicked on him. So yeah, he's going to be very central in this network. In terms of if we move out here, you can see some interesting features that weren't present with the Friendship Network data. We've got this image file here, data. So these are actually the what the people are putting in the NodeXL. Sorry, what the people are putting into Twitter, into their profiles. So I can make this graph show their photos from Twitter. The way I do that is I go to shape and I select image. And I'm just going to do it for a few because it actually pulls the data down from the internet, so it'll take a while to refresh the graph if I do everyone. And so now you can see, so that's Mark Smith there. Okay. So that's how we get pictures in there. Out here, there's other things though of more interest. There is tooltip, which is it seems to be just their username again. Oh no, it's not. It's more than that. So when you hover over the tooltip is what you get when you hover over the image or the node, and what it will show if they've actually authored a tweet themselves. Because not everyone in this data set will have authored tweets, because you'll be in this network if you've been mentioned in a tweet that someone else authored. But if you've actually authored a tweet yourself, then it will actually show the tweet that you authored here below the username. That's the tooltip column. Don't know what that is. This is data coming from Twitter itself. It's the number of people that Mark is, I'll focus on Mark. That's the number of people that Mark is following on Twitter as a whole. So he is following 2,200 people on Twitter. So it's not just this network, it's Twitter as a whole. He's being followed by nearly 5,000 people. He's authored nearly over 2,000 tweets. So this is very interesting metadata that Twitter pulls down that you can get from Twitter for. It's the number of favourites, the number of tweets that he's favourited, and then you get information on, his description. The profile description. This is he describes himself sociologist of computer-mediated collective action, and there's location data and there's time zone data, etc. So that's quite interesting. In the edges page, it's the thing that it's of interest is we actually have information on the type of edge. So we know that the connection between from StemWire to Mark Smith is an @ mention. So that means that StemWire authored a tweet and they mentioned Mark Smith in that tweet. Well, these ones are tweets. So these are tweets that are not either @ mentions or @ replies. Out here you can actually see the tweet itself. So you can actually see the context of the edge. And then there are there's a few other columns here, the tweet date and things like that. So otherwise, apart from these new data that have been pulled down in the edges and the vertices spreadsheet, in terms of how you work with the network, it's exactly the same as what we were doing with the Friendship Network, but now we're just using Twitter data. So what I'd like you to do now is to get some ideas about a hashtag that you're interested in and go through the steps that I just showed you to actually collect. For those of you who've got a Twitter account and would like to collect the data live, this is the opportunity to do that. If you don't have a Twitter account, I'll show you a link so you can download some Twitter data that I've collected. So hands up, how many of you are going to collect data live? Only 1, 2, including me. So no one else has Twitter accounts. No. Okay. Yeah. Yeah. Okay. Okay. So this is interesting. Yeah, I expected more people would have Twitter accounts. So yeah. But you're following. Oh yeah, because when you read other people's tweets, you don't need to have an account. Okay. So it seems like there's only one or two people who are actually going to want to collect live data themselves. Yeah. Well, I can also collect data for you. You know, we can do it live here. So are there any hashtags that people are particularly interested in? Refugee services. Well, this is the way I often do this is I go firstly to Twitter itself. So this is how what I would recommend if you're wanting to look for particular keywords. You go to the search interface first and just see whether or not there are tweets that mention the keyword that you're interested in, and are they the sorts of tweets that you're interested in collecting data on. So I would say that there's quite a lot there about refugee services, so I think it's quite a fruitful kind of term for collecting data. So how about I do that now? Search network, and what I'm going to do is I'm going to collect the follows relationships as well, and I'm going to expand URLs in tweet, but I'm going to limit it to 20. And let's see what we get. So you see down the bottom here, it's telling you where it's at. So it's working. It's finding the people who are followed. Well, we don't get much data, but so for that I could have selected more. So that's not interesting at all. These people just link. They're not tweeting. They're not connecting to one another. So they've all tweeted. They've all created a tweet using the term, but there's no relationships between them. Okay. There's no @ mentions or anything, and none of them follow each other. So this is an example where I probably could have gone back to the last 100, and maybe then I would have got some connections between people. It's not really clear, because it's actually not NodeXL's decision, but it's Twitter's decision. It's not clear exactly what order they return tweets in. I think it's like the most recently authored tweets. I don't think they order them in terms of popularity of tweet. It's like, okay, you search back 100 tweets in time. Yeah, so what I would recommend what you could do is if you just kept on collecting data over time, but then you could use NodeXL to kind of focus on the tweets that you think are most important. Yeah. The other limitation is that you can't go back. There's a window of time that you can search back in. It's only like up to 2 weeks, I think. So if the tweet was authored more than 2 weeks ago, then you can't get it. You know, it's gone basically. Well, you can if you buy data from one of Twitter's resellers.